Okay, so I'm going to explain the other special right triangle that we have. This is actually our 30, 60, 90 triangle. This has another pattern to it, just like the 45, 45, 90. So this is my basic setup right here. I have my 30 degrees, and the side directly across from 30 degrees, we're going to call this A. My hypotenuse here, I'm going to call this 2A. And then directly across from my 60-degree angle is going to be A square root 3. A square root 3. Okay. Just like with our 45, 45, 90, this is going to be a pattern. So let me show you an example with this 30, 60, 90 triangle. On this, so we're going to have a triangle here. This is going to be a 30, 60, 90. Let's call this 30 degrees and this 60 degrees. And I'm going to go ahead and tell you directly across from the 30 degrees is going to be 5 square root 3, and I want to know the other sides. So let's find the hypotenuse first. The hypotenuse is 2A, and then my A is 5 square root 3. So all I'm going to do is play substitution, and I'm going to do 2 times 5 square root 3. Now be careful, when you multiply these, you're not going to multiply the 2 with the square root of 3. They are two separate things. You're only allowed to multiply anything with the 3 if it's under another square root. But I can do 2 times 5, which is going to give me 10 square root 3. So my hypotenuse is 10 square root 3. My 60 degrees is A square root 3. So I'm just going to substitute in 5 square root 3 for the A. And I'm going to have 5 square root 3 times the square root of 3. Now if you notice, these two both have the same square root. When they have the same square root, you're allowed to multiply the numbers underneath. So 3 times 3 is going to give me 9. So I'm going to get 5 times the square root of 9. The square root of 9 is nothing more than 3, which gives me 5 times 3, which of course then is 15. So this side length here is 15.